All right, in today's lesson here, we're going to take a look at some quadratic word problems. These ones are a little more challenging ones, but they're still going to give you quadratics and things to evaluate here using similar techniques. So let's take a look at this first problem here. In this question here, we have a 10-meter metal rope here is being cut. What you're going to do here is the first piece of this metal rope, you're going to turn into a square, and then the second slice that you're going to cut here of it, the second piece is going to turn into a circle. And what you want to do here is you want to find out where should I cut this rope in order to minimize the total area of the square and the circle put together here. So let's take a look here. You've got yourself a rope, and the rope is being cut at some length we don't know. That's what we want to find, x. And then if the rope itself is 10 meters, you can label that a y, but it would be better to label as a 10 minus x because you know the whole rope is 10 meters. You cut this at some length x. The leftover piece is going to be 10 minus x here. And now what you're going to do is with the first shape, you're going to create yourself a square. And the second shape, you're going to create yourself a circle. And what we want to figure out is where should I cut this in order to minimize the amount of surface area that is taking place here, so amount of area. And we'll also look at the idea of maximizing as well. So the first thing you have to do is create an equation for each one of these. So let's put A for area, and the area of a square here, you know the area of a square is just length times width. Now if I have if the whole length I have to work with is x, that would mean that each side of this square is x over 4. X over 4, so the area of this will be x over 4 times x over 4, or x over 4 squared. So actually you get x squared over 16 represents the area of the square. Now for this shape here, you know this is a circle, and we know the area of a circle is pi r squared. Now I don't have my radius, and I want to write it in terms of x here, but I do know the circumference of a circle is 2 pi r. So the circumference of a circle is 10 minus x is going to equal 2 pi r. That'll imply that the radius of the circle is 10 minus x over 2 pi. That becomes the radius of my circle. So the area of my circle is going to be pi times my radius is 10 minus x over 2 pi. So now I have a representation for the area of my square and area of my circle. I want to minimize the total area here. So this is going to be x squared over 16 plus, and sorry, I should have put in a squared on this right here. That's going to be pi r squared plus pi, and then I've got my radius here as a relationship of x squared. All right, so continuing this up here, my total area is going to be x squared over 16 plus pi. I'm going to square the top. I'll leave it like that. I'll actually expand out the bottom as 4 pi squared. And I can reduce this a bit. This becomes x squared over 16 plus 10 minus x squared over 4 pi. All right, so I'm going to expand this out and try to write this as a quadratic. I can see that this is a quadratic, right? The highest power of this is power 2. I can see this quadratic has a leading coefficient. It's going to be positive. It's going to open upwards. I just got to find the vertex, and I'll have my minimum answer here. So I just got to re-express this as a quadratic. So let's go ahead and do that. This becomes x squared over 16 plus 1 over 4 pi. And if I expand this out, you're going to get 100 minus 20x plus x squared, and the total area here is x squared over 16 plus this. When I distribute this, this will reduce to become 25 over pi minus 5x over pi, and then plus x squared over 4 pi. So again, I'm going to collect like terms and put this together. So if I collect up my x squareds here, you'll see I have x squared over 16 and x squared over 4 pi. So putting that together, my coefficient is 1 over 16 plus 1 over 4 pi x squared minus 5 over pi x. It's my b value, and then lastly my c value. So now I've re-expressed my quadratic in standard form, and I can see this opens upwards. And what I want to do here is I want this value right here. So I can complete the square on this, I can find the roots on this and average them out, but the best method would be to use your formula negative b over 2a. So my axis of symmetry, I know the general form of an axis of symmetry is negative b over 2a for any quadratic. So therefore my x value is going to be negative b, so this will end up being, the two minuses will become positive on my b value here. So this is going to be 5 over pi divided by 2 times my a value, which is 1 over 4 pi. So if I punch this into my calculator, you end up getting the axis of symmetry is approximately 5.60. So that means that this should be cut to minimize total area at 5.6. So that means if I give me a piece of rope here, you're going to get minimum right at, it's a little bit past the midpoint at 5.6. And then the other chunk here will be 4.4. And make that out of a, turn that into a square, turn that into a circle, that'll yield minimal total area. Just to illustrate what that total area would be, if I go ahead and go to my total area function and I let x be 5.6, you end up getting that it ends up implying that your total area comes out to be approximately 3.5. Now, this problem, the original problem, if you take a look at it, this is a piece of rope. This has constraints on the rope as well. The rope cannot be any smaller than 0 and cannot be any bigger than 10. So we actually have endpoints that we should check as well to see what those yield. So in that, I mean that if I let x be 0, what you're getting is you're not doing the square at all, and you're just going to take this, not cut the rope, and turn it into one big circle. And if you let x be 10, you're not doing the circle, you're not going to cut the rope and turn it into one big square. So let's go ahead and take a look at what values you get when you do that. So for my total surface area, if I let x be, let's say I let x be 10. So if I'm letting x be 10 here, you can see that you're doing all square. And if you punch this in, you'll find out that your total area comes out to be approximately 6.25. And if you go ahead and let x be 0, and by letting x be 0, I'm doing all circle, my total area comes out to be 7.9. And these are measured in meters squared for each of these units. So therefore, we do have our answer they had asked for. They asked for minimum area, and that comes about when x is 5.6. You get 3.5 approximately meters squared. And maximum area, although they didn't ask it, this is it, happens when it's x is 0, so it's one big circle, and this gives max area. So max area is happening here, and this is your minimum area. All right, let's take a look at another. So in this next problem here, we have a Norman window. And in this Norman window is constructed by taking a semicircle, as you see here, and then you kind of like surmount your rectangle below on this window here. What they tell you in the question is you have, in this problem, 24 meters of perimeter, and that's assumed to be all the distance around this object you're using to build it. That's your constraint. In this case here, my perimeter is 24 meters. And then what they want you to do is what dimensions should this Norman window be to omit max light, the amount of, so in other words, most area coming through this. So the area of this shape is going to be the area of your rectangle. So that's going to be 2x. You can see here they labeled this as x, so it's going to be, this entire thing will be 2x times y. That's the area of the rectangle. That'll be a rectangle, plus the area of my circle is normally pi r squared, so pi x squared. In this case, you can see here they gave us the radius and label as x, but this is a semicircle, so it's going to be over 2. So this represents the area of this Norman window here that I'm looking to maximize. I cannot maximize a multivariable function. I need to get this down to one variable here. So what I'm going to do is use my constraint to my advantage, which is 24. So I know the total perimeter is 24. And this total perimeter is going to be y plus y, gives me 2y. These are going to be 2x apiece. But I'm assuming that the perimeter is only the distance around the object, and they're not putting any wood or anything in this location. So therefore, I've got the base of this is going to be 2x, and then so I've got a 2x here, and then a y and a y. So I'm going to get 2x plus 2y, plus the circumference of a circle is 2 pi r, and my r is x here. But again, this is half of a circle, so I divide that by 2. So therefore, the perimeter of this shape is 24, is going to equal 2x plus 2y plus pi x. So again, I have this formula represented here for the area of this shape. I'm going to isolate for y and try to substitute. I'm going to isolate for y here and try to sub it in here rather than x, because I'd have to put it in twice. So I'm going to isolate for y for this question. So isolating for y, I get 2y is going to be 24 minus 2x minus pi x. Divide across by 2, I get y is 12 minus x minus pi over 2x becomes the area. I'm going to dump this in my formula here. So if I dump this in my formula, I'm going to get 2x. Get rid of the y. You get 12 minus x minus pi x over 2 plus pi x squared over 2. And then let's try to make this look like a quadratic. So I'm going to expand this out. I get, 24x, I should say, minus 2x squared minus pi x squared plus pi x squared over 2. So putting this together here, you can see I can go ahead and let's simplify this first. I've got negative pi plus pi over 2. This is going to give me negative pi over 2x squared minus 2x squared plus 24x. And then cleaning this up a bit, my quadratic is negative pi over 2 minus 2x squared plus 24x. It becomes my quadratic. So now I have myself a quadratic, and you can see the leading coefficient of this quadratic is negative, so this is going to open downwards. And again, I'm looking to, if you read the original question, I'm looking to find maximum area. I just want the vertex of this quadratic. So again, go to your negative b over 2a. So it's going to be negative b, in this case negative 24, over 2 times negative pi over 2 minus 2. And if you punch this in your calculator, you get the following. You get approximately 3.36 for your x value. So that means that's my x value. I have to now go ahead and solve for my y value. So my y value is going to be 12 minus, approximately equal to 12 minus 3.36 minus pi over 2 times 3.36. And if I punch that in my calculator, I'll get my corresponding y value here, which is, also comes out to be 3.36 as well. So putting all this together here, the dimensions that will give you max area are going to happen when your x value is 3.36, or in this case here, you could double that, and you end up getting 6.72. So I can double that, and this can be 6.72, and this is 3.36. So those dimensions there are going to yield yourself max area. All right, this is an example of a Norman window pane question, omitting the most light. All right, let's take a look at one last example. All right, in our final problem here, we have an open box is made from a piece of cardboard. So you have yourself this piece of cardboard here made from this open box. And if you keep reading, it says the width of the cardboard is 5 inches less than the length. So the width of my cardboard is 5 inches less than the length of the cardboard. So I label this my width and my length by cutting 4-inch squares from each corner. So I'm going to cut these 4-inch squares from each corner. So these are 4 apiece, and folding up the sides. So they're effectively, if you cut out these 4-inch squares out of this piece of cardboard, you end up creating yourself a box. So, And you can see the height of the box is going to be 4 when you flip the flaps up. This is like the, we can label this the length. I can label this the width. And they're telling me in the question that my width, if we take a look here, let me move this over here. If I read this question, they're saying that the width is actually 5 inches less than the length. So I can get rid of the width and put L minus 5. So now if I keep reading, it says the volume of the box is 336 cubic inches, and they're asking what are the dimensions of the original piece of cardboard. So they're essentially asking for the W and the L value here. Now, to label this properly here, when we solve for L and W, we'll have to add 8 to these to get the proper dimensions for the actual cardboard itself. But they tell me that the volume of this box, you know, the volume of the box is length times width times height. They tell me that it's 336. And the length is L, the width is L minus 5, and the height is 4. So what I'm looking to do for this is I want to find the original. So if I take 336 and divide that by 4, I end up getting 84 equals L times L minus 5. So I want to solve for L here, and I have this quadratic. I'm going to go ahead and expand this out and bring everything to one side. And I have this quadratic right here. So again, you can factor this, or you can go ahead and use the quadratic equation. If I go ahead and use the quadratic equation, I get L is 5 plus or minus the root of 361 over 2 times A. So I get here the root of 361, that's a perfect square. I end up getting 19, so you get 5 plus or minus 19 over 2. It's going to generate 2 answers for me here. One answer is going to be equal to 12, and the second answer is going to be equal to -7. So it turns out that this quadratic here has 2 values for L. One is -7, the other is 12. The -7 is inadmissible, you're not going to be using that, but the one answer is 12. So in the case here, when I go to solve this equation, right, I'm looking to solve for this, find the values that make this true. I end up finding out that when L equals 12, that ends up giving, satisfying this equation, and that's our solution to this problem here. Now they want to know the original measurements of the cardboard. So the original measurements of the cardboard, you can see here that your L value is 12. So if we go to our cardboard here, my L value is 12. And again, this L represented after cutting out 8. So I'm going to have to add 8 to that. So that means my L value is going to be 20. And then my W value is going to be 5 less, as we discovered, so it's going to be 7. And again, you're cutting out that 8 just the same here. When I go to do my width value, this is going to be 5 less. This gives me my 12. I still have to add up 4 and 4 as well, so add 8 to that, I end up getting 15. So the original cardboard was 20 by 15. Okay, that concludes today's lesson. Just going through some different quadratic word problems here for you. Thank you.